So number 42, you only had A. Coffee is draining from the cone-shaped filter into the cylindrical-shaped coffee pot, and they tell us that it's leaving the cone at 10 cubic inches per minute, which means it's entering the cylinder at 10 cubic inches per minute. So in telling us that, they've told us about the different rates of change of volume. So for the cone, dV dt, since it's leaving, I am losing 10 cubic inches per minute. That coffee, however, is flowing right into the cylinder, so the rate of change of volume for the cylinder, it is gaining 10 cubic inches per minute. So those are two facts for the situation as far as what is my always situation, my permanent, if we're doing pig. So they asked, how fast is the water level in the pot rising when the cone is 5 inches deep? So I'm going to sketch the coffee pot, which is that cylinder. The coffee pot, when the coffee fills up to different levels, is making a different cylinder every time. And the height of that cylinder is changing, but one thing that's not changing is its radius. So if you look at the different levels of coffee, each time that radius is exactly 3 inches. That's going to make this problem a lot easier because that isn't a 4-1 instance situation. That radius stays 3 the whole time. What is going to change is the height of the coffee in the pot. So they would like to know when the cone is 5 inches deep. It turns out that this isn't going to matter in this situation. It doesn't matter what is happening in the cone so much as it matters that I know how fast stuff is coming into the cylinder. So if we needed to do part B, we would need to worry about that. But it doesn't matter what level the cone is at, the coffee is coming into the cylinder at the same rate. So, permanent. Permanent is definitely our change in volume over time. Permanent is definitely our 3-inch radius on the cylinder. And at a specific time, they would like to know when the cone is 5 inches deep, and we'll see if that matters in this. But the height of this, then, is dependent on the radius, and the radius is fixed. So the level in the pot is h. We are looking for dH dt for the coffee pot, not the cone. So as I go to get a volume formula for that cylinder of coffee, that cylinder of coffee is normally, cylinders are pi r squared h. In our situation, our radius is fixed, so this actually becomes 9 pi h. So the only factor that affects the height is the volume. Volume is a function of the height. So when I go to do my rates of change, I'll have dV and dH. Nothing about the cone is going to come into play here. So when I go to do some calculus, the rate of change of volume, okay, with respect to time, is going to be, and when we do the derivative of this, we're going to get 9 pi dH dt. I can sub in then for the volume in the coffee pot. The volume in the coffee pot's rate of change is 10 cubic inches per minute. 9 pi times the rate I'm interested in finding for the coffee pot. So when I do some division, dH dt is going to come out 10 divided by 9 pi, and we're going to be in inches per minute. And then if you go to get the decimal equivalent of that, just please watch your division. It's 10 divided by the quantity, 9 pi, so that if you came up with a decimal value of 0.354 inches per minute, that would be equivalent.